Let's go ahead and look at the solution to this problem. So here we're asked to find the radian measure of some angle theta given to us by a different diagram in each case. So in all cases we need to recall the definition of radian measure. How do we measure an angle in radians? And the way we would do that is we've used the formula theta equals the arc length divided by the radius. Now note that in this first example for our circle we have a radius of 1. Anytime we have a radius of 1 we're working with a unit circle. Say if this was centered about the origin we would be working with the unit circle. But when we have a radius of 1 we can see our theta in this case. So we know this will always be true. But in this case here we can see that theta equals s divided by 1. Or just that theta equals s. Our radian measure of our angle theta is given to us by our arc length, where our arc length is the distance along our circle from where the initial side of our angle intersects the circle to where our terminal side of the angle intersects our circle. So we need to determine that arc length. Now there's a number of ways we could find that arc length. Perhaps the easiest way for us is to recall the unit circle and know that a real number starting at 1, 0, moving pi halves in a positive direction around that unit circle will put us at 0, 1. So we can see that this arc length is just pi halves. Now how else could we have found that arc length? Well, we could have used the definition for the circumference of a circle. So we know that this is going to be, because this is a 90-degree angle we see there, we should have a quarter of the circumference of the total circle equal to the arc length we're looking for. So consider for the circle, the circumference is 2 pi times r, or 2 pi times 1, or 2 pi. And so our arc length in this case should be the circumference divided by 4, which is 2 pi divided by 4, which is pi halves. So for any of these reasons we could say that the arc length is equal to pi halves. And again, in this case we can see that our arc length is exactly equal to our theta, or our radian measure of theta. So we can find the radian measure of our angle theta given by this diagram in part A is just pi halves radians. Awesome. Let's go ahead and look at part B. So in part B, we're again working with the unit circle note. So again, we'll be able to say, because our radius here is 1, that our theta is just equal to the arc length divided by the radius, or the arc length divided by 1, or the arc length. So we must determine that arc length. And note that we know by our ideas of the unit circle what this real number, if I move along from 1, 0, all the way to the terminal point, -1/2, comma -√3/2 is. This terminal point would be the terminal point, or sorry, this real number would be the real number, s equals 4 pi thirds. Because s equals 4 pi thirds and because the radius is equal to 1, here we can say that the radian measure for the angle given to us here is just 4 pi thirds. So we can box around that and move on. So for part C, note now that we're finally not working with the unit circle. Here we're working with a circle of radius 3. So that's the first thing we can note. And we also need to determine the arc length around the circle. So some of the things we can compute pretty quickly and simply. Again, we can see our radius here is equal to 3. And now we'd like to know what is the arc length around our circle here. So to find that arc length, what is the value of our arc length? We will use the equation for the circumference of a circle, and note that we want half of that circumference is the arc length which we're interested in. So we know that our circumference is just 2 pi times r, or 2 pi times 3, or 6 pi in this case. And what are we looking for? Well, we're looking for half of that arc length, or half of that circumference, excuse me. As we know, we're going just halfway around our circle, so we're looking at 6 pi divided by 2, or 3 pi. So we can see our arc length again is 3 pi. And so we could look at the definition for the radian measure of our angle being the arc length divided by our radius, which in this case is just 3 pi divided by 3, or pi. And we find our solution that the radian measure for this angle theta is just pi, or pi radians is the measure for angle theta. Alright, finally let's look at part D. Here in part D, again, we're not working with a circle that is a unit circle, but still our angle's vertex is at the center of that circle. Here we can see our radius is immediately given to us, it's 2, and our arc length is also immediately given to us, it's 3 pi halves. So what is our radian measure of our angle theta, or what is the measure of our angle theta in radians? Well, we'll recall the definition of our measure for the radian measure for any angle theta is just the ratio of its arc length and its radius. So we'll have in the numerator 3 pi halves and in the denominator 2. See, that tells us that our arc length here, or that our angle measure in radians for theta is 3 pi over 4.